Good afternoon, one and all. Today we are going to start the next module. So far, we have completed the first module, that is MAC protocol in ad hoc wireless network. Next, we had completed the routing protocols, and last week we have completed the third module, which is quality of service in ad hoc wireless network. Fourth chapter is, or fourth module as per your syllabus, is little bit different from all this. Directly they had jumped to another type of ad hoc wireless network, a specific type that is called wireless sensor network. And again in fifth module they have come back to hybrid wireless network. So this first, second, third and fifth, these four modules are technology based, whereas the fourth module, that is ad hoc wireless network, it is mainly application based. So as per as my understanding, it will be better if we complete this hybrid wireless network, that is the module number 5 after module number 3rd. And finally, we will check the application, that is the fourth module, which is called as wireless sensor network. It is altogether a different study, different paradigm, which is a type of ad hoc wireless network. But let us first complete the technological understanding of hybrid wireless network, and then we will go for wireless sensor network. Now, as this book that is prescribed as per your syllabus, it is written long back. So by the time the book was written and it was a part of your syllabus, because syllabus is also quite old. At that time, next generation hybrid wireless network, it included optical and WDM and all those things. But now in 2020, all these technologies have become quite old. Okay. So whenever in this module they are saying next generation hybrid wireless network, uh, from this point of view, from syllabus point of view, they were next generation. But as we are standing today, for us, optical and WDM, all those have become quite old technology. So this next generation hybrid wireless architecture is not for today. This part you have to understand. This is as per when the book was written. From that point of view, the technologies discussed is called as next generation. So this is one understanding that we are supposed to have while going through this module. And there are many introductory networks that we are supposed to understand. So only two topics though I have showing, that is introduction to hybrid wireless network, which is called as HWN, and there is next generation hybrid wireless architecture. So 2 3 architectures are there. We will try to cover at least two today. So after we understand all those architectures, then we'll be going for some more protocols, Soprano and other things. So it'll keep on coming step by step. If you have understood the initial parts, that is MAC, routing, QoS, those were very basic paradigms of ad hoc wireless networks. This will not be very different, and some very new fundamentals are not there in this module. Only the understanding that we had, that we have developed so far in first three modules, will be just seen in a different way in this module. So I won't have to explain anything new here, I think. Okay. So this is the 25th lecture. So we have completed 3 modules in first 24 lectures. So we are going as per the syllabus norms, that is 8 hours per module that is there. So let us see what is meant by hybrid wireless network. So before I enter hybrid, I want to just give you a little recap of initial stages. We had seen one type of ad hoc wireless network. One type of network was infrastructure based, another was infrastructure less networks. So infrastructure based network application is the cellular phone, the mobile phone that we use. What is the advantage of that? There is always a base station, and all the calls are routed through the base station. Base station is having abundant amount of energy, so there is no shortage of energy. Base station controls the communication between any node. Base station comes to know about the communication between any node. Okay, and as base station is there, it is easier. The load on the nodes are less, because base station is the main decision maker. So everything happens through base station. So the base station, whenever is there, that is infrastructure based network. It is more kind of a organized network. Okay, so it is not distributed. It is centralized. It is called a CAP, centralized. There is a centralized access point. So base station BS or CAP, they are same thing. They are the main thing. They are the mainstay or the holding point of the whole network. So these are features of infrastructure based network. But the downside is everything is too much dependent on the base station. So if somehow the base station falls or goes bad, the whole network stops, because every call, every decision is routed through base station. And if somehow base station goes bad, maybe due to power failure or something, though it is connected to power supply, but maybe there is a power failure. So sometime it happens in our region, the tower goes, mobile tower goes off. Why? Because maybe there is a power failure or there is a transformer issue. So and base station, that is a mobile tower, is not getting supply at that time. The whole region mobile communication stops. Okay, so this is the downside of infrastructure based network. And if we are talking about ad hoc network, at that time the applications are either in battlefield, or the applications are for disaster management, or for some kind of flood has happened or cyclone has happened. In all those areas we have to go, we have to set up a network, and then the communication will occur. So whenever this kind of very dynamic applications are designed, at that time we cannot depend on the base station. Okay, that there is no facility, there is no infrastructure at that time that we will go in a flooded area and we will be searching for a centralized base station. It's not possible, because everything is down in that case. So in those kind of situation, we cannot expect base station. In that case, we have to just spray the sensor nodes or just fit the sensor nodes at different locations. All the sensor nodes in a distributed manner, not centralized but distributed manner, they have to make the decision. And in that case, they have to take the decision for data transmit among themselves. So this is the second type, which is called as ad hoc or distributed kind of network. There is, or infrastructure less network. So they are constrained by energy, they are constrained by bandwidth, there is no central decision making point. So all these nodes are together, they have to take a decision that how to route the data, how to save energy, how to avoid the congestion in the network, all those things. So higher level decision making has to be done by the lowest level sensor nodes. So in this case, this sensor nodes has to be very smart, because there is no central command, there is no, so this is like a college which is run by only faculties, there is no principal in that college. So all the faculties have to together, they have to make decisions that how best the teaching learning process can go. So this is like a ad hoc network or infrastructure less network. Infrastructure less network is having the advantage of you can say this can be deployed in a battlefield. It takes very less time to deploy the sensor or to place the network, unlike infrastructure based network. Okay, so very fast deployment can occur, very fast they can communicate among each other, and maybe 1 or 2 hour very rapidly they will collect the information and send it to the base station, and all the nodes will die. Okay, so they are comparatively less costly. Okay, they are comparatively highly dynamic and can produce very smart result in very quick time. Whenever very typical kind of disaster management like applications are required, there we can use this kind of ad hoc type of infrastructure less network. Okay, but obviously all the shortcomings of ad hoc network are there in case of this infrastructure less network, but they are having their advantage. What is hybrid network, or what is next generation hybrid wireless architecture? So they are actually combining all the issues, positive not issues, all the positives of infrastructure based network as well as infrastructure less network, and they are coming out with a specific solution, a special solution, where all the positive points of infrastructure based network and infrastructure less network, they are produced. That's why it is called as hybrid. It is difficult. Okay, it is difficult, but it is there. So next generation hybrid wireless architecture, HWN it is called. Whenever I am saying HWN, it means it is a combination of infrastructure based and infrastructure less networks. What are the open issues? So in next generation hybrid wireless network in topic 2, here we will be seeing some 2 3 different type of architecture. They're very important for your exams also. Okay. And then there are open issues, that what are the negatives, what are the issues that are challenges that has to be faced in case of hybrid wireless network, we have to check. Okay. Then how does routing happens in case of hybrid wireless network? A very interesting topic. We have seen routing in case of ad hoc wireless network, routing in case of infrastructure based network. It is very easy, because if any point wants to talk to another point, any node wants to talk to another node, I'm talking about infrastructure based network like our mobile phone, cellular phone. So first it has to send the messages or request to the base station. Then base station understands that this cell phone wants to talk to another cell phone which is there within that cell, or maybe within another cell. Yeah. So in that case, the base station will connect this node with the other node. So that is actually infrastructure based network, but infrastructure less network does not do that. So there are many repeater station, intermediate nodes. So data transfer happens to that. Now, how routing exactly happens in case of hybrid wireless network? So we'll be finding this type of routing is actually using both types of communication or routing. That sometime it is talking to the base station and connecting to the receiver, or sometime it is directly by through intermediate nodes, it is talking to the receiver node. So which are the conditions where it is using direct communication, which are the conditions where some node, transmitter node, is communicating with the receiver node through the centralized base station. Those cases we will see here. So very interesting topic, routing in hybrid wireless network. Then there is coming power control scheme. So we have seen the power control scheme in MAC, in routing, in QoS. Here also for hybrid wireless network, there will come the power control scheme. So this is actually, we cannot think anything about network without power control. At every part of network design, at every aspect, the power control part has to be there. Okay, so for hybrid wireless network also, power control part is there. We will check what different power control scheme are explained here. Then there is load balancing and routing in hybrid wireless network. So this can be a these two can be separate question, that what is the necessity of power control for any network, ad hoc or infrastructure based. What can be the necessity of load balancing in routing in ad hoc network or infrastructure based networks? What is meant by load balancing? Load balancing is nothing but, suppose from the sender to receiver there are 5 or 6 different paths, or there may be 10 different type of sensors, 20 receivers. So there are many paths. Okay. Now from one sender to one receiver, suppose there are 4 or 5 different paths, but we are using one path repeatedly. In that case, what will happen is all the nodes in that path, specific path, that may be the shortest path, that may be the optimized path, but by repeatedly using that path, what we are doing is we are actually exhausting the batteries of that path nodes. Because whenever there is a power transmission, signal transmission taking place, there is power usage. So instead of distributing the transmission load among many paths, if we are using one path repeatedly, then what happens is that path becomes dead, because too much use of same nodes over and over again. So what is meant by load balancing? So there are many types of load balancing. This is one I'm explaining. So load balancing means if there are 5 different paths among the transmitter to receiver, so use different path at different times. So all these 5 paths you use equally, so that every node will be exhausted by 20% amount of time. Instead, one path if we use repeatedly, 100% battery wastage will happen or usage will happen, and that path will become dead. So the best path is dead. So suppose somebody wants to go from point A to point B. There is a sender to receiver. So there are 5 paths, and one path is path one is the shortest. There is the most optimized path. Now too much usage of that path, what happens? The path gets broken. Then by force you have to choose the non-optimized paths. Okay, so that should not happen. So that is one type of load balancing, that is sharing the load among all the paths. And when the route is too busy, suppose again the same thing, point A to B. Now think of road traffic. Point A to B, there are 5 paths. Then all the vehicles wants to pass through path 1. And what will happen? The path 1 will get jammed. Okay, then everybody will be delayed. That is called as overloaded or overloading of one path. Instead, if we do load sharing, that is, if there are 5 paths, we will see that the cars which are not that in hurry, okay, a little bit delay will do. Less important cars, we can divert them to path 4 or path 5. Ambulance and all those who are very much important. So some minister wants to go from path A to B. So ministers, ambulance, school children. So all those things we can pass through path 1, which is the shortest path. And less important, the travelers and other thing, those who are going for holidays, a little bit here and there, a little bit late will do. So them we will channelize through part 2, 3, 4, 5. So this is called load sharing by different paths. So in that case, what will happen? In that case, the path 1 over usage will not be there. In that case, load sharing will happen. So all the paths will be having 20%, 20% of load. Traffic jam will be avoided. Quality of the road will be maintained, because one path is too much used, the quality of the road will become very bad, because every road is having a life. Same thing happens in case of links, data links. So data links are nothing but path that you have to understand, and cars are nothing but, or vehicles are nothing but equal to data packet. So that way, if you understand this, understanding of ad hoc network becomes easy. Okay, so this was the first 6 topics. They can be found out in the 13th chapter of Shivram Murthy, and this is the first part of your module 5. And module 5 is also having 4 more topics that can be found out in module chapter 14 of Shivram Murthy. So there are topics 7 and 9, 10. And though all this 1 to 10, they are part of your module 5, but they are actually spread among 2 different chapters in your textbook 1. Okay. So 7th topic is recent advances in wireless network. So whenever recent is being told, this recent word is actually maybe 10 to 15 years back. Okay, so at that time, the next topics, that is 8, 9, 10, ultra wideband radio communication, UWB it is called, or wireless fidelity, okay, Wi-Fi systems, or optical wireless network, or WDM. All those things were advanced technologies by the time when the book was written. Okay. But now all these things have become kind of obsolete. Okay, but then also we will try to understand the basics of UWB, wireless fidelity, and optical wireless networks, and what kind of communication paradigm they are using. So this is actually coming in the next part. So you can see that a number of topics are comparatively less in this chapter, in this module as per as your syllabus. So every topic is important for exam. So every topic can be a 10-mark question. So every topic is very important for exam, and this module is quite easy. Okay, so don't leave any of the topics which will be discussed. So I'm starting officially the module number 5, that is the introduction for the module 5, which is called as hybrid wireless networks, which is called HWN. So what is meant by hybrid wireless network? What is meant by next generation wireless system? So it have to support a wide range of advanced services, okay, which are difficult to achieve in wireless network due to resource constraint. So generally, wireless networks are constrained by bandwidth. Wireless networks are constrained by uh, energy. Okay, but here in hybrid wireless network, demands are little higher. Okay, we want the best operations. We want the best features of the network, but with lesser amount of uh, cost function, lesser amount of bandwidth usage, lesser amount of battery, but we want best performances. So these are kind of contradictory uh, demands. Okay, so hybrid wireless networks would try to fulfill all these contradictory demands. So they're saying, so they're always in ad hoc wireless network, there are resource constraints. So ad hoc wireless network are nothing but infrastructure less network. So they are already resource constrained network. So for these services, that means for services which are demanded from ad hoc wireless network, infrastructure with high data rate is necessary for next gen voice and data traffic. So this is the demand that ad hoc wireless network are generally not good for voice traffic, video traffic, data traffic, that is high volume data traffic. But then also we are trying to use ad hoc wireless network for real-time voice, real-time data, maybe video and other things. How that can be achieved? Okay, so that can be achieved not by a traditional ad hoc wireless network, but that can be achieved by uh, hybrid wireless network. How they can be achieved? Let us see. Phenomenal growth of internet has found huge need for higher capacity wireless networks, which can. So these are the new features or new demands on ad hoc wireless network. This can be asked in exam. Please prepare. So which can? So capacity, higher capacity wireless networks. So what are the features of higher capacity wireless network? Explained here. So they should be highly efficient to handle big network loads. That means a data rate should be very high in case of hybrid wireless network HWN. Service highly mobile users with smooth handoffs. Okay. So the mobility in a general ad hoc network, whatever was there, that was creating problem of link failure, node failure and all. But in hybrid wireless network, the demand is even if the node mobility goes higher, that means nodes are highly mobile, then also the link connectivity should be maintained. What is meant by smooth handoff? So if the mobile node is going, not mobile phone, it is mobile node, it's a wireless ad hoc node which is moving from one place to another. So previously they were routing through one path, but suddenly now the node has started moving, and then also the link connectivity, the routing path, and all those things should be maintained. Maybe through a different path it will be routing data, but should not say that due to mobility the connectivity between transmitter and receiver is broken. It should not happen. So there should be a smooth handoff. What is meant by handoff? That previously one path was being used for data routing. If due to mobility there may be another path reroute, okay, that might occur, and this change of paths between transmitter to receiver, that is called handoff. Okay, another example is we are traveling by a road and we are using different towers and continuously we are talking over phone. So whenever we are in the range of one mobile tower base station, then if we are leaving that cell and going to another cell, so there is a handoff between this cell to the another cell. So our communication will be handed over from this cell base station to the next cell base station without any kind of interrupt in our talking. So that is called as smooth handoff. We don't understand that we are running very fast in a car. That's why we don't understand that while we had been talking for 20 minutes, maybe six different base stations has helped us to keep our connectivity. So the handoff was so smooth that maybe in this 20 minutes, six different base stations or five different base stations we have covered, and they have smoothly handed the signal from one to the other, from next to the next, likewise. Okay, so this is called handoff. So the change of route, change of central control, all these things should happen from one to the next very smoothly without any kind of drop in message, without any kind of drop in call and all those things. So that is called smooth handoff. So whenever we are designing hybrid wireless network, at that time it has to be seen that highly mobile nodes or highly mobile users with uh, smooth handoff. So this characteristic is maintained in hybrid wireless network. So these are contradictory demands because whenever there is high mobility, then generally smooth handoff is not possible. But this is a very big demand on hybrid wireless network. They have to do this. Offer connectivity. So HWN offer connectivity through a variety of access points. So that is what I'm telling, that whenever we had been, so about mobile cellular network we had been talking, that whenever we are passing through a road by car, so maybe our car is running through 130 kilometer per hour, so five or six different nodes or centralized base stations or access points, you can say CAP. Okay, they have handed my signal from one to other to next, but we are finding a uninterrupted kind of communication. Okay, so that is offer connectivity through a variety of access points. So that centralized access points, they are ensuring that we can keep talking without any kind of disturb, without any kind of packet drop, but call will remain as connected, and we will not come to understand any change of handoffs. Okay. So HWN manages best effort and real-time connections with QoS support and delay-sensitive applications. So delay-sensitive applications is something like previously, maybe for 20 years, if you were making a ISD call and there was a delay, okay, so the delay was quite big. So at that time, the delay was almost 5 to 10 seconds were there. So it was an art to talk in a ISD line. Okay, because you had to talk and you had to wait for a certain time for almost 5-10 seconds. Then you used to get reply from the other side. So if somebody keeps on talking, then the other person will not understand. And then because there is always a delay between when the voice is transmitted and when the voice is reaching to the receiver. In local also there is a delay, but the delay is so less. At that time we don't understand, we don't get to know that there is a delay. But if there is ISD call, it used to take before 10-20 years, it used to take quite a lot of time, 5-10 seconds, for the voice to reach to the ISD thing and their response to come. So it was an art talking over a ISD line. So that is called as communication delay. So whenever we are designing a HWN, in that case, best effort real-time connection and delay-sensitive application. So for voice, if delay is there 5-10 seconds, that does not change the signal, because if we wait for 5-10 seconds, the same thing that the other person is talking, it will reach in my ear and it will make the exact sense whatever that person want to convey. Okay, so talking over telephone is not a delay sensitive application. Okay, the delay can be taken into account and then also we can get the message. But there are certain signals. Okay, if you are delaying that part, some part of it, so those were spatial signals. Let's take an image, it is delay sensitive. Okay, if you are just shifting some pixels from one place to another, just creating a delay. Okay, just shifting it, delay in spatial, okay, not in time. So in that case the whole image becomes different. So something called as phase sensitive, phase insensitive signals. So whenever we are talking about those phase sensitive signals, at that time hybrid wireless networks has to be very highly sensitive, that which signal delay, for which signal delay is not accepted, and for some signals delay is accepted. So the signals where delay is not at all accepted, there this kind of networks has to perform very well, and they have to be very careful. Okay. And obviously we have to give QoS support in hybrid wireless network as well. The data should reach to the receiver within time. The data count, that is number of packet transmitted, should be number of packet received, and the packets data should be unaltered, okay, whenever it is reaching to the receiver. So all these things, whichever was the QoS demands, that is remaining unchanged. So all the data should reach to the receiver by keeping all the QoS demands. And what is another hybrid wireless network feature? That is, it should be flexible with existing infrastructure to form the basis of next generation wireless system. I told you there are two kinds of network. One is infrastructure based, another is infrastructure less. Hybrid actually is combining both. So certain time it is using the infrastructure based kind of communication, that is through the central access point or base station. Certain time it is doing direct communication. So which are those conditions, we will see later on. So there should be flexibility, okay, of communication between transmitter to receiver. Now, what are the different kinds of network? 1G cellular network, it focused on the aspects of frequency reuse, terminal mobility, handoff techniques. 2G, it focused on improving the technology to make a much better reuse of spectrum. So spectrum reuse is a very important thing. We can increase the efficiency of the overall network by frequency reuse, standardizing the 2G technology across the world, and limited data support. That was what is 2G. 3G is extensively used, what we are finding. So 3G wireless network mainly focuses on data traffic support, flexible reuse of resources, seamless internet connection, and support of packet-based real-time traffic. So 2G could not give us that much real-time traffic support, but yes, 3G, 4G, they are meant for real-time traffic support, and we have got enough good support from 3G and 4G. Just check here, 4G is not explained. So by the time this book was written, 4G was not very well established in the market as a use paradigm. Okay, so only they have explained up to 3G. So what is meant by next generation wireless network? So it handles increased volume of traffic. Obviously, if you are transmitting video, if you are transmitting real-time voice, they will be having higher bandwidth, so they will be increasing the volume of real-time traffic. So actually increased number of users and high average traffic generated by users. So number of user is a continuously increasing thing. Okay. Total number of user will keep on increasing every day, that will never be reducing. Okay, and they will be producing too much of highly dynamic data and high density data. So this hybrid wireless network should be able to handle many users, that is many sender, many receiver, robust system, and that also should be able to handle too much of high density data and very fast moving data. So all the demands are being increased every year, or every second the demands are increased. Hybrid wireless network architecture combine multi-hop radio relaying for efficient spectrum reuse. So this is one of the very important features. So spectrum reuse is one of the main thing that hybrid wireless network is using, and excels to high capacity wireless network. So how hybrid wireless networks are increasing the capacity? Just by relaying for efficient spectrum reuse. So this is the technology. I think you are studying spectrum reuse in other network related subjects, so I don't have to explain. Only thing you know, that use of spectrum reuses, it is increasing the efficiency, and amount of volume that is handled by the network is increasing by spectrum reuse. And it provides, that is hybrid wireless network, it provides better data rates at fringes at a cell. So fringes means at the corner. Okay, so at the corner even, so which are generally blind spot kind of a thing, which are created in a cell. So in those areas also, hybrid wireless network should give a seamless kind of communication. So what is hybrid wireless network? So basic ingredient of hybrid wireless network is the throughput enhancement. That means output increasing. That means data handled, data delivered by the network is increasing. Okay, which has happened due to the introduction of ad hoc network characteristic. So traditional cellular network, which are where all the data is being transferred from one node to the other through the base station. Okay, so it was actually sometimes, so sometimes two nodes are very close by. Okay, but then also if it is infrastructure based network, first one node had to talk to the base station, and base station will be sending the data to the receiver node. But these two nodes are ekdam reaching side by side, staying side by side. Suppose me and my friend, we are sitting together, and I want to transfer data to him by using cellular phone. So in that case, I had to first send the data to base station, and base station will again send the data to the person. So this is called as distance insensitive. Okay, so cellular network was distance insensitive. But whenever I'm talking about ad hoc network, so if me and my friend, we are sitting side by side, we are not going to use base station based cellular communication. What we are going to do is we will just turn on our Bluetooth, and a local kind of communication link we will set up among each other. So that is actually helping us save a lot of communication power. That is helping us save a lot of communication time and resources. So that is what is said as it. So it should be a smart paradigm. Whenever two nodes are very far off and all, at that time, if we are communicating by means of base station, it's okay. But whenever two friends are sitting side by side and they want to exchange data, there is no point that they're doing it uh, by using a base station in between. So they can do it on their own. They can set up their own network. Okay. So hybrid wireless network, what is that? So it is a kind of an infrastructure based network which are trying to incorporate the features of ad hoc wireless network into it. So whenever an infrastructure-based network is trying to incorporate the features of ad hoc network characteristics into it, all the good points, then together this thing is called as a hybrid wireless network. Very important feature. So it reduces the power of transmission in ad hoc wireless network, causing reaching the destination in multiple hops. So that is what I told you. Two friends sitting side by side, they are not going to keep bring base station in between. They will set up their own network. They will exchange the data by using Bluetooth. Okay, so here it is actually saving a lot of transmission power, which are being used for multi-hop communication. So it is a well-known technique to enhance the network throughput. So this actually increases the overall output because it reduces power, it increases the speed of the transmission. So overall network output increases. It increases the network service area, okay, and to enable higher data rates due to lesser interference at the receiver node. So whenever two nodes are very far off, whenever I am bringing the base station in between, so from the sender to the base station and base station to the receiver. So obviously their chances of interference are quite high in that case. But if two friends sitting side by side, they're exchanging data by using Bluetooth or some other kind of local ad hoc technology, in that case, the interference becomes very less. So that again, on the other hand, increases the efficiency of the overall network data transmission. So throughput through though this hybrid architectures which exhibit properties of both single hop and multi-hop wireless network, though these hybrid architectures are still confined to research arena. So at that time when the book was written, at that time hybrid communication was a matter of research, but now we are using very high speed hybrid wireless networks. Okay, so at that time when the book was written, at that time it was a research topic, but they are believed to be potential candidates for next gen wireless network. So now it is a next gen wireless network. So hybrid networks we are using quite extensively. They are actually the outcome of the research that was carried out 10, 15, 20 years back. So a concept group which is called as 3GPP. Okay, the full form is Third Generation Partnership Project. So EC engineers must know this. They had initially included the multi-hub relay-based opportunity-driven multiple access. So this is called ODMA, opportunity-driven multiple access. But currently ODMA is excluded due to concerns over signaling overhead complexity and final standard issues. So ODMA was initially introduced by 3GPP, but they are not used now. So we are actually talking about an evolution. So from where it started, how it evolved, and now what is the status of uh, hybrid wireless network now means when the book was written, maybe 15 years back. Okay. So other hybrid net architecture includes the mobile assisted data forwarding, which is called as MADF, ad hoc GSM, AGSM, so directional throughput enhanced wireless in local loop, DWILL, and unified cellular and ad hoc network UCAN. Okay, so these were before 15-20 years. These were the matter of research. Many of them are implemented. Many of them have helped to design hybrid wireless network and increase the data rate through the network in a great extent. So the major advantages of such multi-hub architectures are reduced interference, as I just explained, extended coverage, so they are covering a broader area, broadband support over extended range, okay, increased reliability and support for all large number of users. So main thing, output is increasing, and number of people it is satisfying, number of people it is servicing, so that thing is also increasing. So these are the two main advantages of hybrid wireless network, that it has increased the reachability, that means it is reaching to a lot many more number of people, and the data rate, that is number of amount of data that we are transmitting. So initially it was in kbps, now it is mbps, and it is still going. Okay, so data rate has increased and number of people it is servicing, that also has increased. So that is so this last paragraph are the advantages that this new technologies, so new at that time, MADF, UCAN, AGSM, DWILL, so these are offering this major advantages over the standard base infrastructure based ad hoc network. So whenever we are mixing infrastructure based and ad hoc, at that time all these advantage which are written in the paragraph below, they are being achieved. So here classification of hybrid network architecture. So they're classified as with dedicated relay stations. So intermediate nodes, they are called as relay station, with host come relay stations. So host means kind of base station. Okay, so they are kind of the central access points. So first one is relay station only. That is, this is kind of a ad hoc kind of a architecture. And host and relay station. So dedicated relay stations, they don't originate data traffic on their own. So they are just for relaying the data. So they don't generate data. Okay. So they will just relay. They will take the data from the previous node and they will just relay it to the next node. That's all. So they assist in forwarding on behalf of the senders. So relay node, the first type, dedicated relay stations, they don't generate the data. That means they are not going to sense data. So there is no sensor in the first type, that is the with dedicated relay station. They will just take the data from the previous nodes and forward it. The connection between the dedicated relay stations and the base stations is either by wired link or by using point or point-to-point wireless link. Okay. Dedicated relay stations architecture are of two types. One is multi-mode system, another is single mode system. And what are the differences? So these differences can be asked as short note. Please prepare. In multi-mode system, the mobile hosts. So mobile host is called as MH. It is not Maharashtra, it is MH. Remember, because this MH abbreviation is going to come in next slides in bigger way. So in multi-mode system, the mobile hosts, okay, a mobile host means the data generator. Mobile hosts act either in single hop mode or in multi-hop mode, depending on the architecture. And in single mode system, the image operate only in multi-hop mode. So this you have to understand what is meant by single hop mode and what is meant by, sorry, single mode system and what is meant by multi-mode system. So here we are talking about image. Image is nothing but the mobile hosts. Mobile host means not mobile phone. Mobile hosts means they are generating data because they are host and they are mobile. Okay, mobile does not mean mobile phone. Mobile means they are moving. Okay, so mobile host or image, if they are using single hop as well as multi hop communication, then they are called as multi-mode system. So mode is nothing but how many types of hops they are using. So if the mobile hosts they are using single hop as well as multi hop, those mobile hosts are called as multi-mode system. And if the mobile hosts are only using multi-hop mode, they are not using single hop mode, then they are called as single mode system. So in this case, the hybrid architecture is shown. So here hybrid architecture is there are two types. First type is system with host come relay station. Second is dedicated relay station. So it is told above, with dedicated relay station, this is the second type, and with host come relay station, this is the first type. Host come relay station is again having two types. First one is single mode system. So single mode system is using only multi-hop. Multi-hop means between source to receiver there are many other relay stations. Okay, and single hop means directly sender to receiver. That is meant by single hop. Okay, so source come relay station, they can be divided as single mode system and multi-mode system. So single mode system is having two types, three types. Sorry, first one is MCN. This we are going to see. Second one is MWLAN. MWLAN, and third one is SMCN. Okay, so among this single mode system, we will see only MCN. Okay. In multi-mode system, there are again two types. One is high mobility, one is limited mobility. In high mobility, there is HWN, MUPAC, MADF, AGSM, and UCAN. So among them, we are going to see HWN. And in multi-mode system, so multi-mode system means it can be single hop, it can be multi-hop. So in multi-mode system, there is only one, that is limited mobility system, TWILL, DWILL. This, so we are going to see MCN. So this is one thing which is called system with host come relay, single mode system, and first type. Then we are going to see HWN, which is called multi-mode system, that is system host come relay, multi-mode system, single mobility system, and this is called as HWN. Then we are coming to system with dedicated relay station. So it is not host come relay, it is only dedicated relay. So this second arm of this architecture, or second arm of this classification, system with dedicated relay station, they are not generating data, they are just forwarding data. So single mode system, so single mode system is there for host come relay as well as it is there for dedicated relay. Single mode system means it will be using only multi-hop. So there we are going to see Soprano, a very important, very sought after question by the paper setters, examiners. So this is a third type of uh, architecture that we are going to see. And system with dedicated relay multi-mode, this is having ICAR. Okay, so this is another type of hybrid architecture we are going to. So we are going to see only three types. One is MCN, one is HWN, and one is soprano. So today I think I'll be able to do only MCN. So let us see what is the MCN type of hybrid architecture. So first thing, this is host come relay. That means this will be generating data, and this will be relaying the data. Okay. Hello. Okay. So let us see the MCN type of architecture in coming 10 minutes. So you can see the diagram here. So this is called multi-hub cellular network architecture, which is called as MCN, and there are there's only one slide here, so you will see this. So for best effort communication, all cells. So there are different types of things. So you can check the small things which are there. So like mobile phone, these are actually mobile hosts, and every mobile host is actually surrounded by an area. So there is something called as communication range and sensing range, we have discussed in module 2. So this is actually the communication range of mobile host A, and then there is mobile host C. The second circle is the communication range for mobile host C. Then there is third. Then so this thing is actually the mobile host D, this circle, and their next circle is mobile host D. Likewise, okay. And this is R by K. What is R by K? We will see, and what is R. So there is a base station. So this is MCN, that is multi-hop cellular network architecture. This is having two different kinds of communication. One is if A wants to talk to suppose B. So there are two ways it can communicate. So first, it asks for setting up a link to B, and then this base station, whichever is there at the central access point, this will relay the information of A to B. Oh, sorry, B is here, I'm sorry. Okay, so first A will send the message to base station, and base station will send the message to B. So this is one type of communication, which is simple cellular or mobile phone kind of communication. Second is, I told you that A, C, D, B, they are very close by. So A wants to talk to B. It is not going to talk to base station now. So A initially requests for data sent, then C will tell you, A suppose wants to talk to B, so A just floods the whole network with some kind of request that I want to talk to station B. Where is B? Just tell me. So C now knows that yes, B is in the right side. D also knows that B is in the right side. So through, and they will keep on telling A, okay, I know B. D also will tell A through C that yes, I know B. So you send me the message, I will forward it to B. So in that case, after all this initial talk, A will send the message to C, C will send the message to D, and D will send the message to B. So the whole process will ignore the BS, that is base station. Okay, so that is the local ad hoc based communication. And one another type of communication is infrastructure based communication, where A wants to talk to B. First, A will talk to base station, and base station will relay the message to B. Okay, so these are mainly two types of communication. Here, let us see what happens. So for best effort communication, all cells share a single data channel with transmission range R. That is transmission range is small r. Okay, so this small circles around A, they are actually having a communication range of R. And as all the nodes are same type, so this B is also having a communication range of small r, and a single control channel with transmission range R. So capital R is the transmission range of base station. Here it is shown. Okay, and generally cell is the hexagon, but it is shown as a circle. So base station is having a communication range of capital R, and every node is having a communication range of small r. Data channel is equal to R by 2, and all radius and that for control channel capital R into K is equal to 2 is kept as a compromise between the increasing and spatial reuse and keeping the number of wireless hops to a minimum. That is, it is understood that every node is having a certain communication range. So all these small nodes A and C and D and B, okay, they are having a communication range that is given by R by K. Okay, where I think K is the number of nodes or MH deployed within the area. Okay, so R into K is equal to 2. Okay, that is actually the case, or that is actually the kind of a small r, whichever is decided by that. So on-demand approach is used in data traffic routing protocol, which has route recovery and route maintenance phase. So initially we have seen what is meant by route establishment, what is meant by route maintenance. So whenever there is a breakage of route at that time, very soon a reroute path is established. That is called as route maintenance. Okay, so on-demand approach is used for data traffic routing protocol. So whenever the demand comes, the nodes forward the packet. That is called on-demand routing, which is route discovery and route maintenance. So if C is asked that A asks C that I want to send the data to B, so C first has to find out the route up to B, and then C will tell A that yes, I have found the route, now you can send me the packet. So as soon as A sends the packet to C, C will forward it to B through the newly defined or newly found out route. Okay, so that path is that step is called as route discovery. When source A has packet for destination B, so now I'm coming to what I have already told you. When source A has packet for destination B and path from A to B is not known, what has happened? It sends a route request packet to BS. So A actually requests BS that tell me where is B. Okay, so A is not transmitting data. A is just sending a route request packet to BS over the control channel. So this communication thing is actually the control signal. That is a dashed lines, and this solid lines are data lines. Okay, remember that. So A first requests the base station that tell me where the B is. I want to talk to B. So A sends a route request packet to BS over the control channel. BS responds with a route reply. So BS then tells A that the B is closer to you. Okay, so don't send the packet to me because B was the other side of base station. Then A base station would have used the communication channel with radius capital R to transmit the data to B. If the B was in the other side of base station, but now B is in the same side of A. So base station tells A that B is in your side only, towards your right. So you just ask the next node or right side nodes to yourself to find out where B is. So route reply packet containing the route. That is, base station tells A that you ask C, D, they will send the packet to B. Then A requests C that please take my packet and give it to B. Then C tries to find out where is B. Then C again floods. Again D receives the call because D knows that B is within one hop distance. So A to C, C to D, D to B, all are within one hop distances. So it is sent back. So whenever a route reply is there, it is sent back to A over the control channel. The route is computed by Dijkstra shortest path search algorithm. So A to B path is found out by Dijkstra shortest path search algorithm, and then A sends the packet to C, C forwards the packet to D, D forwards the packet to B, and by the same path the reply comes back to A. That packet is transmitted from A to B by means of C and D intermediate nodes. The source AA, upon reception of the route reply packet, which is coming from base station, transmits the data packet with the entire route information contained in it to the next node on the path, that is to C, which in turn forwards it. This path is also cached in its local route cache. Okay, so ACDB is the called as route cache, and this information is inserted in the data packet or inside the in the preamble maybe, which is actually used for sending the data from A, C, D, and B. So what is the process? A wants to send data to B. A doesn't know where is B. A sends request to base station. Base station tells A that B is in your site, and then A sends the packet to C, D, and B because this route information A, C, D, B is cached because that is there in the route cache, and then A forwards it to C, C forwards it to D, it comes to B, and again acknowledgement comes back, and that's all. If B was in the other side, if B was somewhere here in the other side of base station within radius capital R, then A would have sent to base station would have told it, okay, no, B is there in the other side. So you cannot do it by ad hoc kind of communication. You have to communicate with me, keeping me in between. In that case, A would have sent the data next to base station, and base station would have sent the data to receiver B. So that was cellular communication. And now whatever is happening ACDB, this is actually ad hoc communication. So this is a MCN, multiple cellular network, which is using both. That is cellular type of communication as well as ad hoc type of communication. Hence, this is called as a hybrid network. So after a route cache which is having ACDB data, subsequent packets to the same destination are source routed by using the same path until the RC entry times out or a route break is detected. So maybe that D is a moving node, maybe C is a mobile node, C is going above or C is going out of this circle, so this bigger circle. So in that case, until this path is not broken by node mobility or maybe node dying, this ACDB is stored in the route cache, and that path will be used time to time for the same data transmission from A to B. When C detects a break on AB route, suppose ACDB path is broken somehow, okay, because of mobility, because of node is dead or something. So if C detects a break on AB route, C sends a route request packet to the BS. So then C initially was taking the packet from A and it was forwarding to B. Suppose DB link is broken. Now C will ask base station that I had been using the path ACDB to transmit data from A to B. Now the path DB is broken. How should I transmit data to B? So this is actually called a route maintenance. So when C detects a break on AB route, C sends a route request packet to the BS, which again sends back a route reply to C by telling him that you use a reroute. So then this base station will tell this C node, and this base station will tell C node about a different path. Through that, the C might be able to send A data to B. So that is actually the route request and route maintenance. Both I have explained. So this is a second type of network which is called as hybrid wireless network, HWN. Here we can see base station as well as AC mobile hosts. So all this hybrid wireless network we will see next day. And there is another architecture which is called Soprano. All this we will be seeing next day. So today I have completed only one type of architecture, that is multi-hop cellular network architecture, which is called as MCN. And I stop here. Thank you.